Hi, I'm Matt Meinl, a solution architect at Levyx. Today I'm going to talk to you about our framework developed with Intel's FPGA programmable acceleration pack cards for accelerating risk analytics for the financial industry. So let's jump right into it. The application we've written backtests a trading model that uses options in it heavily. That's important because options have high CPU requirements. So what we're going to do is load up 40 years worth of stock data for 40 different stocks and assess and simulate that, compare the results, and in real life we would decide whether or not to use that in production. So how we do it is we ingest the data for each of the 40 stocks. Then we execute these Black-Scholes option calculations to generate all the possible option values that we might need. We do it once. We ran this once with CPU and once accelerating things using the Intel Area pack card. And then we can complete the process of the analysis. Let's jump into the demo. I'll start up my Jupyter notebook so I can investigate what went on as we ran this. So here are the runs I ran. First, I ran a run with the FPGA using 40 symbols. Then I ran it without the FPGA. I ran this. We're going to connect to the Spark cluster, and then I'm going to show you what the performance improvements are. Remember, in this whole process, we only used the FPGA to accelerate this step 2 of the process, which took many minutes in each case. So when I graph the performance of the pack card versus the non-pack card run, you can see that the end-to-end performance was about a little over 2 times faster using the pack cards without them, which is a pretty big, important thing for me when I'm mating minutes and hours for these things to run. I can jump into the Apache Spark cluster and look at the input tables that were stored in memory in these data frames that were persisted in Optane. Here's a stock HACF that was simulated. That was one of the inputs. Let me jump into the options table. I can read that options table back, show what the first 20 rows, the options table. Here's some of the option prices we calculated. The question is, how many options prices did we actually have to calculate to do this? When I run this query, it shows me that the total number of synthetic stock prices that we used was 3 billion, 3.7 billion, which means that we did about 7.4 billion options calculations in the course of running these applications. Now, one of the nice things about Apache Spark combined with Levyx Xenon is I can use XML to investigate the working memory of my application and see what some of those tables were. So I'll create a temporary view of this so I can do SQL across it. Basically, I'm just registering as a table. I check the number of symbols here. So, yep, I actually have 40 symbols worth of data in my options table, 45,000 distinct spot prices that the options were calculated based upon. That's about right. 40 stocks, about 1,000 different spot prices per stock. And then I can do queries, as I'm investigating to check, that my pricing was right, or other kinds of investigations after the fact. So here I'm just going to select a range of things from there. And here you can see that when I selected that, I'm showing the first 1,000 rows, but this query returned 6 million rows, which is much bigger than you can fit in an Excel spreadsheet or something like that. So this is why you would use this kind of framework to do this kind of large-scale analysis. So let me jump back to the slides and show you some of the results that we got. So after we did all this for both CPU and FPGA, the CPU alone in that sort of phase 2 compute space took 1,380 seconds. Accelerating with the FPGA PAC card, it took 451 seconds, so about a 3 times improvement in that critical phase 2 of this. So in conclusion, what I want you to remember about this demo is we've shown you how you can reduce the total cost of ownership of these types of solutions by up to 50%. It's a solution that uses Intel's latest technologies like Optane and the new program acceleration PAC cards to their best extent. It's pretty easy to use. I was just a Python programmer and able to access all that performance. And it's available now from Intel qualified vendors like Dell and HP. So have a great conference. Hopefully this was useful. Get in touch with us at Levyx and let's see if we can help your financial customers improve their outcomes. Take care.